Okay, in this video we're going to combine a few of the topics we've learned in the past couple videos and perform multiple transformations of functions. So for having more than one transformation for a function, we're going to perform them in the following order. So first we're going to take care of any horizontal translations, which again means shifting left or right. Remember, minus means you're going to the right, plus means you're actually going to the left. Then any kind of reflections, whether they be across the x-axis or the y-axis, followed by any vertical stretches or compressions, and then finally any vertical translations moving up or down. So this is the order we are going to be following. So just for your own knowledge here, steps 2 and 3, we can actually reverse these without any kind of penalty. So we could actually do the vertical stretches or compressions first, followed by reflections. But we want to put the horizontal translations first and the vertical translations last, and then the order for the other two really in the middle. It's not really important. So if you do the vertical stretches or compressions before the reflections, that's okay as long as horizontal translations come first and vertical translations are last. All right, example 5, determine the parent function and list all transformations done to it and be specific. So we have g of x is negative 2 times the square root of x minus 3. Well, our parent function is square root of x. And as far as horizontal translations go, we do have a minus 3 inside the square root function. So that's a shift to the right 3 units. So here in black we have the square root of x, and if we do the square root of x minus 3, it shifts our graph 3 spaces to the right. Next up, do we have any reflections? Yes, we have that negative out in front. That's a reflection across the x-axis. It's not the 2 will come into play in a moment, but for right now, the negative out in front is a reflection across the x-axis. So we can continue to build our function as we go. It's going to take it and flip it over the x-axis. Then our next one is any vertical stretches or compressions. We have a 2 that we're multiplying our function by, so it's a vertical stretch by a factor of 2. Please be aware that it's not a vertical stretch by a factor of negative 2. The negative part is the reflection across the x-axis, so please don't make that mistake. So now it's going to take our graph and stretch it away from the x-axis by a factor of 2. In other words, all of our y-coordinates on this graph are going to be twice as far away from the x-axis as they are right now. So watch that transformation, and there we go. And then is there anything else that we're doing? No, because we don't have anything we're adding or subtracting afterwards. In fact, this last step matches the function itself, so we're done. Part B, we have g of x is 1/2 times x plus 3 in parentheses squared. So our parent function is the x squared function. And first up, do we have any horizontal translations? Yes, we're adding 3 inside the parentheses. So remember, with horizontal translations, with squaring and cubing and such, you're going to have to introduce parentheses to your parent function. So adding 3 is actually moving it to the left 3 units. So we have the x plus 3 squared. There are no reflections because nothing's being multiplied by a negative. This 1/2 that's out in front is a vertical compression by a factor of 2. So we have 1/2 times the expression x plus 3 squared, and we don't have anything else we're adding or subtracting, so there's no vertical shifts up or down. Example 5, part C, we have g of x is the absolute value of negative x plus 2 and then plus 1 outside. So first let's take care of any horizontal shifts. We have a plus 2. Well, our parent function is absolute value of x, so getting ahead of myself here. We have a plus 2 inside the absolute value bars. We'll worry about this negative in a moment. So it's shifting to the left 2 units. So let's go ahead and graph this one so I can get a visual here. All right. And we'll get rid of u and your x plus 2. There's your shift to the left 2 units. Alrighty, and now the negative that we're multiplying the x by is a reflection across the y-axis. So what we're going to see is by making this x negative, it's going to flip our graph across the y-axis. So let me do that again just so we can see it. So here it is now. Notice it's at negative 2, 0 at the base of this function here. If I put the negative in front of x, it flips it over the y-axis, and now it's at positive 2, 0. So kind of did a little hop there, so to speak, but it's actually a reflection. We don't have any vertical stretching or compressing, but we do have a +1 outside the function. So the +1 that's outside is a vertical shift up 1 unit. So now we're going to take this graph in red and move every point up 1 unit. And there's our g of x graph. All right, part D, we have -1/5 times negative x minus 7 in parentheses cubed minus 4. Wow, it's got a lot going on in this problem. First of all, our parent function is x cubed. I'm definitely going to graph this one. So here's x cubed. And let's get rid of this. Do we have any horizontal shifts? Yes, we have a -7 inside parentheses. So that's going to shift our graph to the right 7 units. So let's do x minus 7 in parentheses cubed. And it moved our graph to the right 7 units. Next up, reflections. We actually have a couple. So we have the negative in front of the x. That's a reflection across the y-axis. So if we make this x negative, it's going to flip this graph over the y-axis like a pancake. Now I want a pancake. So there's our reflection across the y-axis. I'll just do that again so you can see it. Here it is right now, and then making the x negative flips it over completely. So just like a pancake, like in the movie Uncle Buck. It's a vertical compression by a factor of 5 because we are multiplying the whole thing by 1/5. 1/5 is between 0 and 1, so the factor is the reciprocal of 1/5, which is 5. So this is going to press downward on our graph. So now each point, because it's a compression, each of our points will be 5 times closer to the x-axis than they used to be. So we have a 1/5 out in front. Looking at the red graph, let me hide the black graph for a moment. Put this out in front. Not that I don't think it really matters. But notice it pressed downward on it, and how it is right now, by pressing downward on it by a factor of 5, it kind of widened out the graph a little bit as well. Alrighty, we also have a reflection across the x-axis because of the negative that's in front of the 1/5. So we actually can do 2 reflections of this graph, and now we're going to flip this graph over the x-axis, and it's like, you know, John Travolta in Saturday Night Fever. Staying alive, staying alive. No? Okay. I had fun doing it, so whatever. Finally, any vertical shifts or vertical translations? Yes, we have a -4 afterwards, so it's going to move everything down, our graph down 4 units. So now we're just going to take the elevator 4 floors down, and there is our graph. Here's what we started with. Here's what we ended with. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.